Welcome everyone. Today we're going to be designing a 3D printed charging stand for the DualSense 5 controllers. The unique feature of this charging stand is that I'm going to be utilizing magnetic connectors to charge and hold the controllers in place while they're on the stand. This provides some bonus features such as being able to quickly connect the controllers so you can get right back to gaming. So without further ado, let's get right into the video. I'm going to start things off by going through my thought process for choosing the components for this project. The first thing that I wanted to think about was how I was going to get power to the actual controller. First way I thought about doing this was using the 4 pins on the bottom of the controller. This is pretty common in PlayStation 5 controller charging docks. In fact, this is what Sony themselves does in their DualSense 5 charging dock. But I didn't want to go through the process of designing the circuit and the connector for interfacing with these pins on the bottom, so I threw this option out. The second option that I looked into is far simpler, much more direct option of just plugging a USB-C port into the DualSense 5 controller. There's a lot of implementations that I've seen of doing this, but all of them are relatively the same, where it just fixes a USB-C connector in place and you push the controller, locking it into the connector and providing power to the controller. This option I also didn't want to go with because I didn't want something connecting and disconnecting to the port via a physical connection, because I was worried about the internals of the port being worn down over time. This led me to a third and final option, which comes in the form of these magnetic charging cables. Now, these magnetic charging cables work by leaving the connector itself inside of the device that you want to charge. So in our case, that's going to be USB-C connecting to the USB-C port on the back of the DualSense 5 controller, and leaves a magnetic connector on the other end that will snap on to a cable with some pins present to transfer the power. A quick search for these connectors online shows that they are available from a variety of different retailers at an assortment of different styles and quality and prices. For this project, I'm going to be going with the Terrasaco magnetic fast charging cable, which comes in a 4-pack from Amazon. This cable, as mentioned in the description here, provides up to 3 amps, meaning I can do quick charge 3 over this connector. The main reason I'm going with that is because it comes in a 4-pack, and I have other devices that I want to charge using these cables. The PlayStation 5 controller itself can only draw a maximum of about 1.5 to 2 amps from sources that I've seen online. So if you're looking to save some money and want to use these cables only for charging your PlayStation 5 controllers, you can go with a less expensive option. If you're interested in following along, this is what I used, and the links will be in the video description. Once the charging cables had arrived in the mail, I was ready to model them up in Fusion 360. The reason that I decided to model up the charging cable in Fusion 360 was so that later on in the design process, I could use it as a visual aid to see how my tolerance looks and align the PlayStation 5 controller with where I wanted to connect on the charging stand. So we're going to speed right on through this process and enjoy. With that out of the way, now we can move on to modeling the actual charging stand. What I started off by doing is sketching on paper the rough shape and approximate dimensions of the stand. This helped me get an idea of what it was going to look like when it was done in my head and help speed along the CAD process. The dimensions aren't super important here because they can be tweaked later on, but I just wanted to get this thing in 3D so I could look at it and see if there's anything that needed to be changed. The last thing that I did in this roughing it out process was to add some color. again, this is just helping me get a better visual idea of what it's going to look like when it's done. So now that I've gotten the basic shape that I want for the charging stand in CAD, I'm going to be bringing in a model of a PlayStation 5 controller that I found online, which was designed by this gentleman right here. And what this is going to allow me to do is tweak the shape of my design to better fit the PS5 controller, as well as get the proper positioning for the charger on the back of the controller. What I'm going to be doing is downloading the SolidWorks file and importing it into Fusion 360. And I'll come back when I do that. Go to the action section here and click open. This will open up the SolidWorks file and a new design. And all we're going to want to do here is save this design. So I'm going to save it. I'm going to take off this one here and hit save. This will save it over to my data panel over here. Once it has finished saving, I'm going to go back to my design for the charging stand. I'm going to save this design as well. Then to import the controller to this design as an assembly, I'm going to make sure that I have the top level of the design selected, and then I'm going to just drag the controller in. Once it's in, I'm going to rotate it to the position that I want using the wheel over here, bringing it horizontal, and then I'm going to move it up to approximately the right position. Doesn't have to be exact because we can move it later on. So that's pretty close to what I want, and I'm going to hit OK. To get the other one, we're going to do this one more time. Next, I'm going to be designing these slots that go into the charging stand that will hold the magnetic charging cable in place. To aid in aligning this slot, I'm going to be importing the USB-C connector that we modeled up earlier into the model for the controller. To do this, I'm going to open up the data panel, grab the model, and drag it in. Looks like it's upside down, so I'm just going to rotate that 180 degrees. Press OK. I don't actually need the cable in this model, so I'm going to open it up here, hide that. I'm going to show just the USB-C connector, hide the cable, then use the align tool to bring the USB-C connector to the back of the controller. Press OK. To make sure that the connector stays with the controller when we bring it into the other assembly, I'm going to be creating a rigid group. To do that, I'm going to make sure I have the top level selected. I'm going to go to Assemble, Rigid Group, Select, press OK, and then save the design. Now when I go back over to my charging stand, I can see that the PS5 controller model is out of date. I'm going to right click that, get latest version. The model will update, and then we can see that the USB-C connector is present. To see where the USB-C connector lines up with our charging stand when the controller is in its resting position, we're going to be using the project tool. To do this, I'm going to select New Sketch, select the surface I want to sketch on. I'm going to capture the position of the controllers. I'm then going to make it so I can see the face of the USB-C connector. I'm going to go to Create, Project Include, Project. Then I'm going to select the geometry I want to project, which is going to be the outside ring of the USB-C connector, and then I'm going to press OK. And as you can see, it has now taken the outline of this connector and projected it onto this sketch plane. I'm going to hit Finish Sketch, and then I'm going to repeat that for the other controller. Next, onto the cable routing. To do this, I'm going to be using the projected outline that we just created as a reference on where to place the magnetic charging cable inside of the stand. Because the magnetic charging cable is going to be inside of the stand, we need a way to get it there. The way I chose to do this was to print that center piece in 2 separate parts and then join them together afterwards with screws, sandwiching the magnetic charging cable in between. So what I'm doing here is just adding some screw holes and some insets so the nut and the head of the screw would not interfere with the side panels, and I could use shorter screws. Next, onto the dovetail joints. Dovetail joints are a type of joint that restrict the motion between 2 pieces to 1 degree of freedom. This joint can later be combined with either another joint, or a bolt, or a screw to restrict that last degree of freedom and prevent the 2 pieces from coming apart. In this case, we're going to be using it to restrict the side panel to only being able to slide up and down along the side of the stand, and then we're going to be using a screw or 2 to hold it in place. These joints are super common in woodworking when you're making furniture or boxes or something else where you don't want a whole bunch of screws showing. With that, all the CAD is officially finished. Now all that's left to do is slice up the files with your favorite slicer and get them printed. Once your files are printed, the assembly process is pretty straightforward. All you do is take the magnetic charging cables, press them in place, sandwich the other side on, put the screws through the 5 holes present in the side, put a washer and a nut on each of the screws, and tighten it down. Once this is done, you can take the side panel, slide it into place, put a M3 nut into the 4 slots present on the bottom of the centerpiece, and use 4 screws to hold the side panels in place. If you're interested in making one of these for yourselves, all the links you'll need will be in the video description. If you enjoyed this video, please like and subscribe, and I'll see you in the next one.